Including the thermal effects of a wall material is often important, but it doesn't necessarily mean that it's always necessary for the wall to be meshed as a solid zone. A number of options are possible in Fluent for treating conduction within the wall. The first one is to mesh the wall as a solid zone, so you mesh the wall in the preprocessor and assign it as a solid zone, which you see in the image over here, and then heat can flow in all directions within the solid. So this is a most thorough approach. However, despite the fact it's the most thorough approach, it's not always necessary or even practical to be able to mesh the wall when the wall is relatively thin. So the other options involve treating the wall as a thin wall without meshing it. In option 2, only the fluid region is meshed, and then the wall thickness and wall material are specified in the boundary condition panel, and conduction through the wall is accounted for in the normal direction like you see in the picture here. In option 3, shell conduction is also selected in the wall boundary conditions panel, and this results in the creation of a layer of virtual cells, which are used to compute conduction not only in the direction normal to the wall, but also in the plane of the wall, like we see in the picture on the right. Thin wall modeling is worth explaining just a bit more. For options 2 and 3 on the previous slide, where you don't mesh the solid in the preprocessor, then the setup panel in the wall boundary conditions looks like you see here in the graphic on the slide. If you specify the material and the wall thickness, then that will result in option 2, where conduction normal to the solid is computed. In addition to these, if you specify shell conduction, then this will create a layer of virtual cells, which results in option 3, where you can have heat transfer both in the normal direction and in the direction parallel to the wall. One current limitation of the virtual cells is that it's not possible at the moment to export those for fluid structure interaction. For cases with large numbers of shell conduction walls, like you might see in an automotive underhood simulation, the shell conduction walls dialog box, which you open by going to Define and then Shell Conduction Walls, provides a means to manage all of the shell conduction boundaries in a single easy-to-use panel. You can use this panel though and still go to individual boundary condition panels for individual walls and change the shell conduction parameters. In the Set Shell Thickness panel, if you want to set the same thickness for all the walls, then after you click on Set Shell Thickness, you simply enter a value for the thickness and click Apply, and that then gets specified for all of the walls that have been selected as shell conduction zones. If you want the walls to have different thicknesses, then there will be an entry in the panel for the thickness of each individual shell conduction walls, and you can specify those one by one.